In this video, we're going to take a slightly different approach using my trusted sidekick Maple as we further explore these parametric curves. Now, in the previous video, I kind of gave you an introduction and how you can do some really simple things with parametric curves. But as you might imagine, if the equations become more complicated, then doing stuff by hand isn't very efficient. So what I have here, I have some code already set up, and I'm just going to go through and execute line by line, and then we're going to look at some plots, and then I have some nice animations and stuff here. So let's take a look at the first one. It might be a little hard for you to see in the video, but here, the parametric equations that we're going to take a look at, the plot is x equals 3 plus 5t and y equals t minus 2. So here is the x equation is first, and then the y equation is second. And then over here, again, you can't have a set of parametric equations without, okay, what range of values of t are we going to use? So our t value will go from -5 to +5. And then these x and y values here, that just represents the standard range on your x-axis and your y-axis. And then this thickness here is just saying how thick the line's going to be. That way we can see it nice and clear. So I'm just going to enter this, and there we go. So we have the equation of a line, right? So again, nothing super special about this. It's a line. We can see the y and x intercepts. We can identify some ordered pairs. We could find the slope and all that stuff that you can do with a line. And I just want to show you, if you were to change certain things, if I only changed the plus sign in the x equation, so if I made it 3 minus 5t, let's see what will happen. I'm going to delete that, put a minus there, hit enter again, and look at that. It seems like it naturally changed the slope of the line. In fact, there are two ways I could change the slope of the line. I changed the x equation to have a -5 coefficient of the t. Let me put a negative in front of the t in the y equation. So let me make that -t minus 2. Let's take a look at this. It switches the slope again. And still a slightly different line. If you remember, it has a slightly different y and x intercept there. At least I think it does. Right, so that's the equation of a line. Nothing super special there. Let's look at our next plot. Now, this one is similar to one of the examples that we did in the previous video. I looked at x equals sine of t and y equals cosine of t, and we got the standard unit circle, right? This one, I put a 3 as the coefficient of both the sine function and the cosine function. So I'm going to go ahead and enter that, and there you go. We see a circle, but it's not the unit circle. You can look at the circle and tell that the radius is 3. Right? The unit circle would extend from a center of 0 up to no more than an x value of 1 there, y value of 1, and then go all the way around like this, right? In fact, if you want to, I could plot the unit circle as we did by hand. I'll just change both coefficients to 1, hit enter, and there is our smaller circle. Small in the sense that it has a smaller radius, but it's still centered there. Yep. Now, what if I were to change, let's say I made that coefficient a 3, but I kept this coefficient a 1. Let's see, would that make a difference? Surely it should make a difference, right? Is it still going to be a circle? Let's see. Ooh, no, now it looks like I've kind of stretched the curve in the x direction, right? Where the y values still only go between +1 and -1, but now the x values go between -3 and +3. And actually that kind of makes sense, because if you think about what this coefficient represents for your trig function, it represents the amplitude, which we usually think as vertical, but remember this now just represents the x variable. This is our x equation. So we're now saying that x will go from -3 to +3. What if I made this even a little bit bigger? Let's say I made it 4. Can you predict what's going to happen? Yes, so now the y goes still goes between -1 and 1, but the x goes between -4 and 4. And what I'm illustrating here is just by changing just a couple things, just a few things in these parametric curves, we can change the visualization that we are presenting, right? It's very easy to go, and you'll actually see it in the animation when you can make that change kind of fluid, and all of a sudden you see these graphical changes just occur right before your eyes. All right. Okay. So there's some circles, and these, by the way, did I say it? Yeah, these are ellipses, right? These are ellipses. Okay, the next one doesn't really have a nice shape, or a name, I should say, but certainly an interesting curve. X is equal to t squared, and y is equal to the sine of 2t. So again, I'm just going to hit enter and let Maple do its thing, and there you go, an interesting curve. Definitely not a function, right? Y is not a function of x, and x is not a function of y either, because this curve fails both the vertical and the horizontal line test, right? But so even though we can't claim that it's a function, it's certainly something we can visualize, and it actually looks pretty cool, right? Looks pretty cool. All right, let's do one more here. I'm not going to read out what these equations are. You can, if you pause the video and take a look at it, the x equation is always before the comma, and then the y equation is always after. So let's hit enter and see what this comes up with. Ooh, this looks like some fancy cursive, writing almost. But again, just thinking about, I don't even know if we could find a function y equals f of x, right? This one, yeah, because it's not a function. Again, it fails the vertical line test. So we couldn't find a nice y equals f of x that would give us this pretty cool pattern of a curve. But parametrically, it's pretty easy. When you look at what we have here, pretty nice stuff. All right, so we have 3 more. The other 3 are animations, right? So that's why the command is a little bit more involved. And when I hit enter, you're not going to see anything. You're like, wait, where's the animation? Well, animations have to be played. So I'm going to select my plot, and up here I'm going to adjust the frame rate to make it just a little bit slower. I'm going to do 5 frames per second, and then I'm going to hit play, and then we'll see what this parametric curve looks like. And the parametric curve here is it's where it's showing as I increase t, right? So basically now, instead of just plotting everything all at once like it did here, it's going to show you how it would trace it out like you were drawing or writing it on a piece of paper, right? So let's see what it looks like. And there it goes. There you go. So it's like you're writing it, and this is we're generating this by using different values of t. And I started at t equals -5, and then it's going to go off the plot. Oh, and there it is. It stops at t equals a +5. So if you notice the difference between these 2 plots, the end result is the same. The second one really shows you how when you change the parameter t, you're getting these different x, y points that are being plotted. So it actually shows you how this one will be traced out. Let's do the same for this one. I'm going to hit enter, and what is this one going to be? Again, doesn't look like much now, and I'm going to slow it down so it doesn't go too fast. 5 frames per second is pretty good. I'm going to hit play, and ooh, I'm seeing lots of, well, I can't really call them I mean, the cross section is a circle, but it looks like, a coiled spring, circular spring, and let's see, does it join up at the end? Yes, it does. Look at that. Now, I'm telling you, there is no way. I mean, there are equations out there, right? There are implicit equations out there, but they're complicated. It could be several lines of variables and stuff like that. Whereas something pretty simple like this, right? A couple cosine functions for your x, a couple sine functions for your y. And again, here, notice what I did. I'm just going from 0 to 2 pi. But again, this one, and what's interesting is, you know, if I wanted to, I could kind of drag it back in reverse. But basically, you know, when I do something like this, and then let me go forward again, it's like I am just kind of tracing this thing out, just drawing it point by point. But Maple obviously does a really good job. All right, so there's that one. In fact, let me go ahead and let it finish it. Here we go, just continue. All right, so the next one is kind of there's a parametric curve in there, but I am not, okay, let me have it show up and then show you what's going on. So we have a sine curve, right? Basically, it's actually just the sine of x. That's the sine of x. But instead of going from 0 to 2 pi, I just went from 0 to 4 pi. So it's basically 2 cycles of the sine wave. But what I am doing parametrically is I am saying, what if now you have this object? Or what if you were this blue ball and you're going to move along the sine wave? What would your motion look like? Well, we know what it would look like, but we can use a parametric curve to animate that motion. So at t equals 0, you are right at the origin because the sine of 0 is 0. If I go ahead and animate, in fact, yeah, let me go ahead and reduce the frame rate again. And then let's do play. There it is. So as my t changes, and here you can see, it's just giving you the decimal approximation of it. But as t changes, you can see the position on the curve changes as well. And we're going to go from our origin to, right now, we're going to come to a stop at t equals, well, we're at the ordered pair 4 pi, because that's the x value, comma 0. That's the y value. So we're at that ordered pair, and this is if you were to take your calculator and do 4 times pi, you'd get approximately 12.566, right? And if we wanted to, we can go in reverse and say wee, and go back to our start. There we go. So I just wanted you to visualize some of these parametric things. They're no more mysterious than your regular curves. I happen to think they're so much cooler than your regular curves because all you have to do is just change a few simple numbers and you get some rather interesting patterns, right? So next up, we're going to look at, okay, what is the calculus of some of these things, like our nice fancy cursive curve right here. What if we wanted to find the slope of the curve right at this point, and all we were given was the x equation and the y equation? Well, it turns out it's not too difficult at all. So stay tuned for that video, and I will see you soon.